Welcome back to Chapter 5, and we are going to start Section 4 by talking about medians and altitudes of the triangles. Remember, we are within the triangles in this chapter. A few things to review from Section 1, the mid-segment. We also learned in Section 2, we talked about perpendicular bisectors in that point of concurrency being called the circumcenter. And then Section 3, we talked about angle bisectors in that point of concurrency being the incenter. Moving on to altitudes and medians. The median of a triangle is the segment formed when you connect the vertex and the midpoint of the opposite side. And the point of concurrency of those medians is called the centroid. So the point of concurrency of three medians of a triangle is called the centroid. So again, you are going to connect the vertex with the midpoint of the opposite side. So again, the vertex in the midpoint of the opposite side. And wherever those three medians meet is actually called your centroid. Moving on to altitudes, so it's the perpendicular segment from a vertex to the opposite side, or the line that contains that opposite side. And note that this is not the same as the perpendicular bisector, so we have to make sure we can differentiate the two. And the point of concurrency of these altitudes is called the orthocenter. So the point at which the lines containing the three altitudes of a triangle intersect. Now the altitude is a little bit more complex because depending on what type of triangle you have will depend on where your orthocenter is. So notice of an acute triangle, your point of concurrency is inside the triangle. On a right triangle, your orthocenter is on the triangle. And then the obtuse triangle, your orthocenter has to be on the outside of the triangle, and we will kind of look as to why that is. But just make sure you guys draw all of these things down on your paper, and then we will talk about them a little bit more in the lesson. Alright, continuing on with our note cards of this section. This will be note card number 8 for this chapter. When we talk about the concurrency of medians of the triangle. So the median of the triangle intersects at a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. So knowing that, we can say that the median of the triangle is 2/3 the distance from the vertex to the midpoint of the opposite side. So from BF, we can say that BP, so from the vertex to the centroid, is 2/3 the distance of the whole median, BF. So BP is 2/3 the distance of BF. And then looking at the rest of them, AP is 2/3 the distance of AE. And then last, CP, so from the vertex to the centroid, is 2/3 the distance of CD, the whole length. If you wanted to kind of switch that around, you could say that DP, so from the midpoint to the centroid, is 1/3 of the whole length, CD. So there's a few different ways you can kind of change up that equation. And remember, point P of this equation is called the centroid. Alright, let's use that in an example on the next page. So using the centroid, and as soon as you see centroid, you should automatically go to medians, which you should automatically think of the 2/3 rule. So we know that M is the centroid, so we know that GL is our median, And we know that GM is 6, so we want to find ML, and we also want to find GL. So we do know from the vertex to the median, so GM is 2/3 the whole length, which is GL. So we can fill in the blank with 6 equals 2/3 of our whole length. And remember, to solve this algebraically, we are going to multiply that by the reciprocal. So 3/2, knowing that when you multiply, you're going to take 3 times 6, which is 18, divided by 2, which would give me 9. So that whole length, GL, is going to be 9. So now we need to just find ML. So if one part, the whole part is 9, and I have some of it to be 6, I'm just going to subtract. So I would say ML equals GL minus GM, what I already have. So 9 minus 6 gives me a value of 3. So now I know ML is 3, and I know GL is 9. Alright, go ahead and stop this video and make sure you're stopping it to do a problem on your own, and then you can check your answer, not necessarily just writing down the correct answer. So go ahead and do checkpoint number 1, and then check your answer with mine, and then we will continue on with example 2. So we are going to find the centroid of our triangle. So right now we are given the values of J, K, and L, and we want to find the coordinates of the centroid P. Remember, centroid meaning I'm going from the vertex to the midpoint, and I want to be 2/3 from the vertex. So we're going to sketch the triangle, then use the midpoint formula to find the midpoint M of JL, because we want to find the midpoint of JL because that's where the vertex is going to meet the other side. So, using our values, we would say 1 plus 7, remember x1 plus x2 divided by 2. And then we would say y1 plus y2 divided by 2. So we would get 8 divided by 2, which is 4. And we would get 6 divided by 2, which is 3. So our midpoint will be 3, 4, 3. So there's M. So we are going to create our median by going from our vertex straight down to our midpoint M, because I know that both of those sides are equal. And we know that the centroid, point P, is going to be 2/3 that distance from each vertex to the midpoint of the opposite side. And I know that point K is at 6, and I know that M is at 3, or I could just count down 1, 2, 3. So I know that my median is going to be 3 units. So the centroid is going to be 2/3 that distance, which is 3. So 2/3 times 3 is going to give me 2 units. So I need to count down 2 units from K to give me my centroid, point P. Let me use a different color so we can actually see. Point P is going to be right there. So now I need the coordinates of point P. So I know it's over 4, and I know from K minus 2, I'm going to go down 2. My coordinates of point P are going to be 4, 4. Alright, moving on to the next page, our altitudes, where they get a little bit more complex, so we really need to make sure we understand what is going on. So the point of concurrency of altitudes, the lines containing the altitudes of the triangle are concurrent. Remember, concurrent meaning intersecting or connecting at some point. And remember that point A, where those 3 perpendicular lines meet, is called the orthocenter. All right. So moving down to example 3, we are going to draw and connect to see what the orthocenters really do look like. And remember, from the beginning of this section, we talked about on a right triangle, our orthocenter was going to be on the triangle. For an obtuse triangle, the orthocenter was going to be outside the triangle. In the acute triangle, it's going to be inside. So we need to really make sure we're looking for what type of triangle we have, and then where is my orthocenter going to meet. All right, so look, you might need a straight edge for this. So looking at we have a right triangle here, and we're going to try to find point P. So I'm going to draw from there straight down perpendicular to this side is going to be here. So that's perpendicular. And then again from this point straight perpendicular to this other side. So notice I have 2 perpendicular segments. Now I need to draw it from this vertex perpendicular to my other side. So where those 3 meet is going to actually be right here at that the vertex of where my legs meet. That's going to be point P, our orthocenter. Now the orthocenter of the obtuse triangle gets a little tricky. So first off, let's start out with drawing the perpendicular segment from this vertex. I'm going to go draw straight, and then I'm actually going to extend it because I know that it's going to be outside. All right, my next point or vertex I'm going to draw perpendicular. Now notice if I go anywhere up here, there's never going to be a perpendicular segment. So from this vertex, I'm going to extend this side because I am actually going to be perpendicular to the outside portion of that line. And then last, here is my other vertex. I need to extend this side because I'm going to be perpendicular here. So notice now I have my orthocenter, point P, which is outside. And that will just take a little bit of practice, and we will continue to practice that. So don't necessarily worry if you don't get it right now. So go ahead and stop this video and do the next 2 checkpoints. And again, just try the drawings. Don't necessarily think you have to get them right now, but just try them. Alright, moving on to example number 4 to finish up this section. We want to prove that the altitude to the base is an isosceles triangle, or of an isosceles triangle, is the median. So we are given that ABC is isosceles with the base AC. We also know that BD is the altitude of AC. And we want to prove that BD is the median of ABC. So the legs AB, and that should be CB, of the triangle are congruent. We also know that angle ADB and angle CDB are congruent right angles because BD is the altitude. That was given. We also know that BD is congruent to BD because of reflexive, so we know that these 2 triangles are congruent by the HL congruence theorem. And now we know that AD is congruent to CD because CP, CTC. So point B is the midpoint of AC by definition. Therefore, DB intersects AC at the midpoint, making it the median. So here is the last checkpoint. Hope you have a great day.